equation, and we're asked this question actually a few different times on the quiz. So we'll talk about what those different scenarios are, but the first thing that we want to do is find the value of the discriminant. So we have to know the formula for the discriminant is b squared minus 4ac. It's actually part of the quadratic formula. It is the part that goes underneath the square root symbol. The entire quadratic formula needs to be memorized. For this test, this particular piece, we have to know that that's what the discriminant is asking. Another common mistake is that sometimes students will keep the square root symbol as part of the answer for the discriminant, and you actually don't need that. So it's just the number that goes under the square root. So when we take a look here at identifying A, B, and C, so we can see that A is 1, B is negative 4, and C is negative 12. When we plug the pieces in, it's going to look like this. So it's going to be negative 4 squared minus 4 times 1 times negative 12. Notice how we're using parentheses in all of the positions every time we're plugging in a number. Now we want to be especially careful with that negative 4 squared in front. In fact, that's what we have right over here on the sideboard. When you square a negative, it's going to turn into a positive. So negative 4 times negative 4 is positive 16. If you're typing this into a calculator, you have to type parentheses in around your negative 4 before you square it. The other thing you can do is you could just do 4 squared. You're going to get the same answer. So that ends up being positive 16. So I'm going to write that here first. Now, the other thing I'm noticing here is what happens behind that is we have a double negative here. So I want you to think of this as negative 4 times positive 1 times negative 12. Well, if we think about multiplying across here, so negative 4 times 1 is negative 4. And then negative 4 times negative 12. We have a negative times a negative, so that's going to turn into a positive. 4 times 12 is 48. So 16 plus 48 gives us our final answer of 64. So that's all we're doing for part A. Now, the type of number that this is going to inform how many solutions we have and what types of numbers they are. And so if you get a perfect square number, like 64, we can take the square root of that. That means that we are going to have 2 rational solutions when we solve this. So if you think about going all the way and solving with the quadratic formula, when you're taking the square root of 64, that equals 8. And so you're not going to have the square root symbol in the answer. If you don't have the square root symbol in the answer, you're just going to get a regular whole number or like a regular fraction. Those types of numbers are called rational numbers. All right, so now we're going to do a little bit more work with that particular equation. We are going to now solve it, and we're actually going to solve it 3 different ways, side by side. So the work looks different, but we should still get the same final answer at the end. So starting off here with the first method of factoring. First, we want to get this factored. Now, this is a basic trinomial, so we want to find what multiplies to negative 12 and adds to negative 4. So in this case, that's going to be negative 6 and positive 2. So that's how we can fill in our parentheses here. X minus 6 multiplied by x plus 2. Okay, so once we have this factored, some people got it factored beautifully and then just stopped there. We want to actually keep going. We want to finish the problem. We want to solve this for x. We want to find what values of the equation make this true. So how we do that is we set each factor equal to 0, and we solve each one separately, and this is going to give us 2 different answers. So to solve my first equation, I'm going to add 6 to both sides. We get positive 6 is my first answer. Over here, we're going to subtract 2 from both sides, so negative 2 is the second answer. Now, I should get those same 2 answers when I'm using these different methods. The method, the process, the work that we do is the part that's going to change. All right, so let's talk about the second method here of completing the square. So anytime we're completing the square, the first thing we need to do is move the c value to the other side. So in this case, that's going to be adding 12 to both sides, and that's going to give us x squared minus 4x. We're going to leave a little bit of space before the equal sign. Now it turns into a positive 12 on the other side. Now we're going to complete the square. Now when you do this on the test, I want to see all of your steps for how you're figuring out what number gets added onto the end. And the way you start that is you would put a little arrow below that middle term, so it's going to be like below the -4, and I want to see your work here in the parentheses. We're going to take the b value, in this case it's -4, divided by 2, and then square it. All right, then we're going to show -4 divided by 2, that's -2. And we're still squaring that, that's going to turn it into a positive 4. Okay, now here's the thing, we need to keep this equation balanced. And so if you add 4 onto one side, we have to also add 4 onto the other side. So I always like to circle it so that it stands out on my paper, and I can make sure that I did the same thing on both sides. Now the whole reason we did that step of completing the square to add the 4 onto the end is so that we can factor it into something that looks like this. Perfect square trinomials are always going to factor into a quantity in parentheses that's being squared. And let's carefully fill in the parentheses. So we can always think about with these, the square root of the first term. We're going to list that first. The second. All right, so let's take a look at the middle term. So see how it's being subtracted. So that means that we need a minus sign. And then at the end, we're going to take the square root of the last term. Well, the square root of 4 is 2. Another thing that we can think about is whatever you have right here, right before it gets squared, that -2, that's what's going to go down into the parentheses. All right, and then we are going to add the numbers here on the other side, so 12 plus 4 is equal to 16. All right, so the next thing we need to do then is square root both sides. So we've done all of this work so that we can do the square root method. Now, it's simple on the left side. It's just going to undo the squared symbol. So that just ends up being x minus 2. And then on the other side, the square root of 16, that has 2 square roots, positive 4 or negative 4. So this is where we're going to write the plus or minus sign out in front. Before you split it into the two possibilities, you could add 2 to both sides. So you could write it as 2 plus or minus 4. And this is going to give us 2 answers here. So on one side, 2 plus 4 is 6. So notice how that's the same thing that we got over here. On the other side, 2 minus 4 is -2. So we did this a totally different way, but we still ended up getting the same answer. Okay, so now this is where we're going to think about identifying A, B, and C, which is actually kind of familiar to us. So we did that in the first problems, the discriminant at the very beginning. The discriminant is actually part of the quadratic formula. One thing I want you to know, you have to know the quadratic formula. This does have to be memorized. This is not a formula that's given to you. This is one of the most important skills that, along with factoring, that you're going to take out of this class into future classes. If you don't know the quadratic formula, you actually will not be able to do 24% of the test. So like the highest grade you could get is 76. That's if you score perfectly on everything else with no other mistakes. So you have to know the formula. If it helps to just try to look at it and write it down on paper and then look at it and check, I always like to think about the song, the Pop Goes the Weasel tune, so that's what I'm going to do here. I always think about the song when I write this down. So I'm going to do x is equal to minus b plus or minus square root b squared minus 4ac all over 2a. Just going to make a little note over here that we must know this. About a quarter of our test on Friday is based on something related to the quadratic formula. Now, once you have the formula written down, then it becomes very simple to just plug the numbers in. We do want to be careful when we have a negative b value, because it's an extra negative sign out in front. So actually, it's going to turn into a positive 4. Inside of our square root symbol, it's going to be negative 4 squared minus 4 times 1 times negative 12. On the denominator here, that's going to be 2 times 1. All right, so let's start to think about simplifying this down. So this is going to be a positive 4 in front. We've actually already done the work for the number that goes under the square root symbol. This is what we did in part A. So that's the discriminant. It's b squared minus 4ac. So the step 2 should look familiar. Negative 4 squared is 16. It is not negative 16. Negative 4 multiplied by itself is going to equal a positive. So it's positive 16. Then we can do negative 4 times 1. That's negative 4. Multiply that by negative 12. A negative times a negative is a positive. And 4 times 12 is 48. All right, and then 16 plus 48 is 64. Notice that that is a number that we can take the square root of. And that's why we get rational solutions. They're not irrational because we don't have the square root symbol in the answer. So we're going to keep going with this. So it's 4 plus or minus 8 divided by 2. We can split this up here at any time. We can split apart that plus or minus. So one possibility is to do 4 plus 8 divided by 2. On the other side over here, it's 4 minus 8 divided by 2. Well, for the first possibility, 12 divided by 2 is 6. So that's the same as the first answer we got, or the other method. 4 minus 8 is negative 4. And negative 4 divided by 2 is negative 2. So 3 different methods. Our work looks different, but we got the same answers of positive 6 and negative 2 the whole time. And what we have coming up next are some questions really similar to what we started with at the top of the page. So we're finding the discriminant, which we talked about at the start. It's just b squared minus 4ac. That's all the discriminant is asking for. What is that number? So in the next problem here, a is 1, b is 3, and c is 4. So on this one, it's going to be 3 squared minus 4 times 1 times 4. So this ends up being 9 minus 16, and this is actually going to go into the negatives. It ends up being negative 7. Anytime you have a discriminant that is a negative number, this is when we are going to have imaginary solutions. And that's because that's the number that goes underneath the square root symbol. If you take the square root of negative 7, that's the scenario that we can rewrite that with I. All right, the next one here, number 3, this is at the top of the back side. And here we're finding the discriminant again. So this is where a is 1, b is 8, and c is negative 6. So I always like to start in the same way, just identifying a, b, and c. This time, when we do b squared minus 4ac, we have 8 squared minus 4 times 1 times negative 6. 8 squared is 64. And I'm going to kind of think about this multiplication going from left to right. So negative 4 times 1 is negative 4. And then negative 4 times negative 6 turns into positive 24. So the final answer here for the discriminant ends up being 88. Now, I'm noticing here that 88 is a positive number, but it's not a perfect square number. So I'm just going to notice here it's positive, but it's not a perfect square. If you weren't sure, you could always just find that square root symbol on your calculator and just try to take the square root of 88 and see if it's a whole number or not. This one is not. And so if this is the number that goes underneath the square root symbol, that means that we're going to have a square root 88 in the answer. It might be a square root type number that we could simplify down. In this case, we could simplify it into like square root 4 times square root 22, but we're still going to have the square root symbol in some capacity in the final answer. And so that's when we have irrational solutions. Irrational solutions have the square root symbol in the answer. So the only scenario that we didn't have with the discriminant is if the discriminant ends up equaling 0. So if b squared minus 4ac is 0, that's when we don't have anything under the square root symbol. And so we don't have the plus or minus square root part because it's just a 0 on the end. You only have one solution. And actually, the solution that you have is minus b over 2a. Because the entire plus or minus square root part just goes away if you have a 0 under the square root. All right, so this one is now wanting us to rewrite the equation in vertex form by completing the square, and then we also want to identify the vertex. So we have to know vertex form looks like this. So we have that A in front. It's the format that has the H and the K. HK represent our vertex. That's why it's called vertex form, is we can just look at the equation very easily and just take the numbers out to get the vertex. So right now we have something that's in standard form. And the process that we're going to use to convert it is utilizing completing the square. Now the way this starts is very similar to solving an equation by completing the square. We're always going to move the c value over to the other side. But notice that this is not 0 over here. That's y. So we still have the y in the problem. We're just going to write it as y minus 10. Now, in order for us to be able to complete the square, we can't have that 3 in front of the x squared. And so we have to divide those two terms by 3. It's like factoring out 3 as a greatest common factor. It's not totally a greatest common factor because we need all the x's to stay on the inside. The only thing that we're taking out is just the number 3. Now when we do 3x squared divided by 3, that gives us 1x squared. That's what we want. Negative 18x divided by 3 is negative 6x. And then I always leave a little bit of space before ending the parentheses, because that's where we're going to complete the square. We're going to add a number onto the end that makes it a perfect square trinomial. All right, just like we did on the other problem on the front side, we're going to show all of our steps here for completing the square. So now it's going to be negative 6 divided by 2 squared. Well, negative 6 divided by 2 is negative 3. And 3 squared is positive, negative 3 squared is positive 9. Now, what's a little different on this one is what we're going to add to the other side. We need to make sure that this is balanced. Whatever we do to one side of our equation, we need to do the same thing to the other side. Well, the 9 that we just added was actually inside of a quantity that's being multiplied by 3. If you were to distribute the 3 to all the terms, that's going to turn into a 27. So we're going to multiply that by the 3 in front to figure out what number is going to get added to the other side. So we're not adding 9 to the other side. We need to actually add 27 because that 9 is really multiplied by 3. All right, let's keep going with this here. The left side is going to be easy for us to simplify here. We still have the y in front, but now we're doing negative 10 plus 27. That's the same thing as 27 minus 10. So that's going to be positive 17. So that's the new version on the left. All of the work that we did here on the right is so that we can rewrite it to look like this. Notice how that 3 just drops straight down. It's still in front of the parentheses. That's actually the a value of our vertex form. It's x squared minus 6x plus 9 that we're factoring into the parentheses part. Now, it's a perfect square trinomial. That's why we completed the square. So let's do the square root of x squared and list that first. The middle term is being subtracted, so it's minus. And then we're doing the square root of the last term is 9. We're listing that second. Now we're really close to being done. The only thing that we need to do is move the 17 over to the other side. And we'll do that by subtracting 17 from both sides. And we'll go ahead and write that at the end. So that is our final answer in vertex form. The last part of the question is wanting us to name the vertex. So the x value of the vertex is the opposite sign as the number in the parenthesis with the x. So that's going to be positive 3. The y value of the vertex is the same sign as the number at the end. That's the part that we call k, and so it's going to be negative 17. All right, so the first thing that we can take a look at in part A is to think about, like, how can we write this so that it's not the square root of a negative? And so we can actually split this up to be the square root of 16 multiplied by the square root of negative 1. So always pull that negative out. And the reason that's helpful is because the square root of negative 1, that's I. So that's another piece that I would say we need to know. We need to have that memorized. Square root of negative 1 equals I. I is just a shorter way of writing the square root of negative 1, but it means the same thing. The square root of 16 then is 4. On these, you don't have to write the plus or minus sign in front of your answer because the square root symbol was already given to us in the problem. When that's the case, we just assume the positive version of the square root. If you put the square root symbol into the problem, like you're doing the square root method and you decide to square root both sides, that's when you have to do the plus or minus. All right, all we're doing here for part B, so this one is going to start off really similar. So let's rewrite that as the square root of positive 24 multiplied by the square root of negative 1. The square root of negative 1, again, we can rewrite that as I. And then we want to check to see, so I can't perfectly do the square root of 24, it's not a square number, but we want to see if we could simplify that or reduce it. And so this could actually be split into square root 4 times square root 6. 4 times 6 is 24. And we split it in this way because I'm trying to find something that I could take the square root of. And the square root of 4 is 2. So I can actually write this as a 2 in front of the square root of 6, and then just keep the I on the end. So that's as far as that one is able to be simplified. Okay. Part C. We want to be really careful on this one because the only thing it is asking us to do is add these numbers together. In fact, off to the side here, let's write the word add. We're not multiplying these together. I know it looks a little confusing when you have two sets of parentheses. A lot of times our brains think, okay, we need to multiply, we need to FOIL. That's what we've done in the past when we see this. But if you have a plus sign in between them, we're just adding the like terms together. In fact, you could write this without parentheses, 3 minus 5i plus negative 1, like this, and then plus I at the end. And then we're just combining like terms. So the real part of the number goes together. 3 minus 1 is 2. And then the imaginary part goes together. So negative 5i plus 1i is negative 4i. And that's our final answer. I'm going to write off to the side here. No FOIL. We're not multiplying. Here we are just adding. So here's what's going on in the next one. Now, notice that the parentheses are not touching. Notice that we have a subtraction sign. So I'm going to write off to the side here. This means subtract. It's really similar to adding, where we're going to think about combining like terms. But the difference is that we have to distribute the subtraction sign. I like to do that first. Meaning everything that comes after the subtraction sign is being subtracted, both parts, not just the first one. And so if we were to write this one without parentheses, it's going to be 4 plus 2i minus 3. Now when we subtract negative 3i, that's going to turn into plus 3i. Then we're just going to combine like terms. So we're going to put the real part together. 4 minus 3 is 1. And then the imaginary part goes together. 2i plus 3i equals 5i. So I think that adding and subtracting are easier operations than the multiplying and dividing. So we don't want to do any more work than we need to. So again, we're not using FOIL, we're not multiplying those out. On part C and D, we're just adding and subtracting. Now, here's where it's going to change. Look at the difference here in part E. Look at those parentheses. They're touching. I don't see a plus sign between the parentheses. I don't see a minus sign between the parentheses. That is the only situation that, yes, we are going to multiply. And yes, we can think about using FOIL or the rectangle box method to multiply all of the pieces. All right, so let's think about this. I'm going to use some arrows. If I'm thinking about FOIL, so I'm going to do the first term times the first term. 1 times 4 is 4. That's the F. All right, for the O in FOIL, so that's the outside term times the outside term. So that's going to be 1 times negative 5i. That's negative 5i. It's just multiplying it by 1, so it's going to stay the same. So that is the O. All right, when we talk about the I in FOIL, we mean the inside terms. So the inside terms would be positive I times positive 4. It's going to be plus 4i. And then finally, the L is the last term times the last term. This is the one we want to be careful of. So it's positive I multiplied by negative 5i. That does not equal negative 5i. It's negative 5i squared. A lot of people just wrote this as negative 5i. Make sure that when we have I multiplied by itself, I times I is I squared. So the reason that's important is because I squared is negative 1. So that would be another piece that would be super helpful to memorize. I is the square root of negative 1. So I squared is negative 1. So then when that gets multiplied by this negative 5, that's going to turn into positive 5. Okay, then we're just combining like terms. So let's put the real part together. We have a 4 in front, we have a positive 5 at the end, so that's going to be 9. Then the imaginary parts goes together. Negative 5i plus 4i is negative 1i. You can write it as negative 1i, or you can just write it as minus I. Okay, so a lot of you did great on the first step here. So the first step is to multiply the numerator and denominator by the conjugate of the denominator, which everything is the same, but it's like the opposite sign. So this is 3 plus I, so the conjugate is 3 minus I. And whatever you do to the denominator, you have to also do that to the numerator. Now, because we had 2 terms on the numerator, let's put parentheses around them. We also had 2 terms on the denominator, so we're going to put parentheses on the denominator. This is just 2 multiplication problems. We're going to FOIL across the numerator, and we're going to FOIL across the denominator. All right, it doesn't matter the order you do this. I'm going to start on the top. I'm going to do 2 times 3, which is 6. 2 times negative I. Negative I times 3. The last one we always need to be real careful with. Okay, so negative I times negative I. So first, we can think about doing the numbers in front. Negative 1 times negative 1. That's positive 1. Okay, so I'm going to put a plus sign. I times I is I squared. Now, if we keep going here on the top, I squared is negative 1. So let's combine like terms. We have a real 6 at the front. We have a real negative 1 at the end. 6 minus 1 is 5. Then for the imaginary part, we have negative 2i minus 3i. That's negative 5i. So that's as far as we can go, simplifying the numerator. On the denominator here, 3 times 3 is 9. I had a few folks writing this as 6. Just be real careful with your multiplication. I know it's easy to get mixed up what's happening. You do have a calculator with you, so you can always check those calculations using that. Then we have the outside is minus 3i. The inside is plus 3i. So something very nice is going to happen with that. Now we're going to be really careful with what's happening at the end. So now it's a positive 1 multiplied by a negative 1. There's an invisible positive 1 here. There's an invisible negative 1 right there. Well, a positive times a negative is a negative. So we need to carry over a negative sign. I times I is I squared. Now, I squared is negative 1, but there's a negative sign in front of it. A negative in front of the negative 1 is turning it into a positive 1. So we have a real 9 in front. We have a real plus 1 at the end. That equals 10. Now, the minus 3i plus 3i, those are going to cancel. It will always work out that way when you multiply by the conjugate. That's why we use the conjugate to divide. So then, what we have over here, we're almost done. The last thing that we can do is split the numerator and keep the denominator the same. So we have 5/10 minus 5/10 I. We could actually go one more step because 5/10 is the same thing as 1/2. So that would be our final answer. What we need to do for solving this one here, we're going to solve using substitution. So one thing that you could do is take the whole thing that is equal to y in the first part, plug it in for y in the second part. And that's going to end up looking like this. Now, this one is great to just solve by factoring. All of these that I give you of the systems, you will be able to do that. We need to get everything on one side, and we want to also simplify. So let's move the 2 over, so we get it set equal to 0. The 7x could combine with the negative x, so that's plus 6x. And then we have a plus 5 at the end. This is going to factor into x plus 5 times x plus 1. So we get 2 answers for x. Some people will stop here. If you got negative 5 and negative 1, that's beautiful. But when we're solving the system, we're trying to find the intersection points. So we need to have 2 ordered pairs for the answer. So we need to also find what's the corresponding y values. So I'm just going to say here, as one final note, we're going to plug in the x values to either equation. I would probably do the second one, that might be easier, to get the corresponding y values.